Okay, this is my second XNA tutorial. In the first one I talked about the Visual Studio Integrated Development Environment, or IDE, and the methods used in XNA. So we're almost ready to start coding, but not quite yet. Every project should really be planned to some degree. A wise person once said, "Weeks of programming can save you hours of planning." And there is truth in that. Now, real AAA titles spend months in pre-production. A cheaper Facebook type game might spend only a few weeks or days in the planning stages. We're doing something even simpler, but we still ought to spend a minute or two deciding exactly what the game's going to do. Or else we could end up spending way too much time testing and debugging it. At the same time, this isn't a place for a discussion of game design documents or technical documentation. No, I'm just going to quickly knock together what we call pseudocode. Pseudocode is pretty much the same thing as structured English. In other words, it's not real programming code, it's plain English, but it's structured the same way as program code would be. So once you have some pseudocode, all you need to do is turn each line of English into the code to do what that line says. That way we concentrate on what's called the algorithm, which is the order of instructions used to do something, rather than the syntax, which is the specific way those instructions are written for that particular programming language. So in fine Blue Peter tradition, here's some I made earlier. A game which I've called Scourge, based on the old game Nemesis. You can see the similarity there. And there's the author and the pseudocode. This is one way to write pseudocode, and this particular piece of pseudocode explains the XNA system at a very high level. One of the good things about pseudocode is that you can take individual parts of that and expand on them to a lower level if necessary. In this case, the update game step is the part that needs the most clarification, so that's what I'm going to do. This is a good start, but it's too vague. How do you move the player? How do you move the enemies? You could put them in their own pseudocode, I suppose, but this one is kind of small, so let's build it up a bit instead. So this is the same pseudocode in a bit more detail. I've left the last step, checking for collisions, still quite vague because it's a pretty big step. In fact, I'm not going to do it just now. I'll do it later, so I'll leave the pseudocode for later as well. Don't worry too much about this pseudocode, by the way. As beginner programmers, you probably won't know what to expect, and you can't write good pseudocode without knowing some of what you expect to have to do. In other words, knowing how to plan your program better goes hand in hand with actual programming experience. So you'll probably notice that some of the lines in this pseudocode have spaces in front called indents, like so. In programming, an indent is used to indicate that one piece of code is part of something bigger. In this case, there's lines of code that are part of some statements that start with the word if or for. An if statement is called a condition. That means that the indented code only runs when that condition is met. For example, the move line only happens if and only if the player goes outside the bounds. A for statement, on the other hand, is a type of loop, but it still has a condition attached. The indented code might run many times, only once, or not at all, depending on the condition. For example, the first loop in our pseudocode goes through each enemy in the list. The condition that this implies is that we keep looping until there's no more enemies left. So if there's none to begin with, the loop doesn't run at all. And if there's one enemy, it runs once. If there's two enemies, it runs twice, and so on. It might be worth mentioning that there's an if statement inside the for loop, right here. When one code subsection is inside another like this, it's called nesting. This is really handy because we can now go through all the enemies using a for loop, for example, and each one will decide independently whether to fire a bullet using the nested if statement. Right, so this pseudocode explains roughly what to do to make the player move, make enemy bullets spawn, make enemies themselves spawn, and make them all move. So let's turn that into actual code. It's going to be a side-scrolling shoot 'em up. Now first we need a project. So file, new project. I'm going to store this in a folder on the C drive that I've just created called XNA. And of course it can be called Scourge. So I'll make a new game with that name and we'll start adding the things we need. I'm actually going to copy that pseudocode into the actual code, but I'll use symbols to make it a comment. Here's that pseudocode. Copy. And because it's part of the update function, that's where I'm going to paste. I'm going to actually replace that comment that said to do, because I'm going to write in more detail what I'm going to do. So there it is, we're getting lots of error messages, that's what those red lines are. But this isn't really code, so I'm going to turn it into a comment by a slash and an asterisk. You can see it turns green. And at the end of the commented section, we have an asterisk slash, the same in reverse. I'll just put in a bunch of tabs to tidy that up a bit. So this is really just a reminder of the code that we have to do. Now I'm going to start with the bad guys. Because you don't know exactly how many there will be at any one time, we need to create a list to store them, not an array. And because each bad guy needs a screen coordinate and a direction to travel, it might be best to combine those things, so that we only need one list to store all those numbers. One way to do this is to use a thing called a class. Now I know I said I'm not going to do object-oriented programming, but believe me, if you speak to somebody who does real object-oriented programming, this is not it. The word class is used to let C# know that we're creating or declaring a class structure, and the name is chosen by us. I've called this one sprite. Notice there's indented code. Remember, that means these two lines are part of something else. So these two lines are part of the sprite class, and we do that by putting them inside curly brackets, or braces to give them a technical term. Now the indented code declares that each sprite will contain two vector2 variables and that they'll be publicly available. What that means is that other things in your game can access them. If they were private instead, which is the default, then only other things inside the sprite would be able to access them. A vector2, by the way, is a two-dimensional vector. It's just two numbers called x and y, which are usually used to indicate horizontal and vertical. These are floating point numbers, which means they can store decimal places if we need them to. We use one for the bad guy's position on the screen in pixels, and the other one to store how fast he is moving, both horizontally and vertically. So next we need to use that class structure to create a list of bad guys. I'll do that in the initialize function, and again I'm going to take out the comment that's telling us we have to do something because we are doing it. So what we do is we say, oops, sorry, I've missed a step. I forgot to declare the list. So the declaration is done up at the same area as declaring the class, and I'm going to call it bad guy list. Sorry, capital L, just to stick to standard. And that is a list of sprites. So the word list tells C# that we're creating a list of objects. The word sprite inside angle brackets tells it what we're making a list of. And then bad guy list is the name, the identifier we've given it. Okay, now we can do the initializing. So that bad guy list, which was initially null, when you create it it's null, which means it doesn't really exist, it's just a name. But now we're going to make it exist by saying that it's equal to a new list of sprites. And whenever you use the keyword new, it calls a constructor, kind of like this constructor here for your game. The sprite has its own constructor. We didn't write one, but it has one nonetheless, and it's still a method just like this one, so it needs brackets. That's why there's brackets here. So although we've created the list, it's an empty list, but it's now stored under bad guy list. And incidentally, we can use the same sprite class to create the bullet list and the player himself. The player, though, is not a list of sprites, he's just one sprite. So to declare and initialize him is slightly simpler. Let's make the list of bullets first. So it's still a list of sprites, and it's going to be called bullet list, surprisingly enough. The player, though, is just one sprite, so we missed the word list and the brackets, the angle brackets, and just say sprite player. Similarly, to initialize the list of bullets, bullet list is a new list of sprites. The player, though, is just a new single sprite. It still has to have brackets because it's still a constructor. Now we need graphics to draw. These are called texture 2Ds in XNA. We could store them in the sprite class too. That would work, but it would mean we'd have to load the bad guy graphics, player graphics, the bullet graphics from disk every time we create a new sprite. So instead, we'll declare 3 basic texture 2D objects. Player graphic, graphic, bad guy graphic, and imaginatively enough, bullet graphic. Then we need to import some graphics into the content pipeline. I'm going to be using some public domain files I found online, which are free and legal to use, but you could always design your own spaceship graphics. To add them, right click on the content folder over here and select add existing item. Now let's find them. Where did I put them? Here they are. Bullet pick, control click on enemy ship and player ship, and hit add. 3 PNG graphics added to your content pipeline. I recommend PNG for a number of reasons. XNA, I don't believe, handles GIFs as standard, and it does handle JPEGs, but they are best used for actual pictures, photographs. Anything that can have a transparency, JPEG can mess with that because of its lossy algorithm. So I recommend PNG for sprites. While I'm at it, I'm going to right click on this image and show you a couple of things in the properties. So this is the properties dialog that's just appeared. So the first thing is the asset name. The asset name is bulletpick. The file is bulletpick.png. So the asset name by default is the same as the file name, but missing the extension. You can actually change the asset name if you want, but that's important because when you load in your code, load the graphic, you refer to it by asset name, not file name. Next, the color key. The color key is hidden under the content processor because it's loaded as a texture, and there's the color key there. It's enabled at the moment. If there's no transparency, you can disable that, but it is enabled. And the color key color is 4 numbers, 2550, 255, 255, and if you see them in the list format, they've got letters next to them. So that's red, green and blue, and alpha. Alpha is how transparent that color is, and the R, G and B values determine which color is the transparency. You may have noticed when I showed you the images earlier, they had a purple background. Purple is full red, full blue and no green. So everything that's purple, it's got to be exactly that shade of purple though. Everything that's purple, technically they call it magenta, is going to be transparent when you actually draw it. Now to load these images, go to the load content method. Again, take out that to do comment and add some lines like this. Player graphic equals content dot load, and in angle brackets tell it which type of content, and then inside regular brackets tell it the asset name. Now the asset name, as you can see from this pop-up, is a string. Strings must have quotes around them. We type in playership, not playership.png, because we use the asset name, not the file name. Next, same thing for bad guy graphic. It's not popping up. Did I forget to initialize it? Oh, there's a typo. Right, it's in the list now. Bad guy graphic equals content load texture 2D, enemy ship, and last but not least, bullet graphic, exactly the same. Now we're finally ready to tackle that pseudocode for the update method. The first line is to move the player, but actually there's 4 different directions, and for now I'll use the keyboard for the player controls. Each key needs to be handled individually, like this. Each if statement has brackets, and inside the brackets is the condition we're looking for. In this case we're checking the keyboard, getting the state of the keyboard, and checking if a particular key is pressed down. Not the down key, which is an easy mistake to make. We're not looking for the down key, we're looking for a specific key and finding out if it's been pressed down. And the key we're looking for is the left key, which we refer to as keys.left. So keys is just a list of different options, enumerated type I should say, and it lets you choose individual keys from the keyboard. Be careful with the brackets here. There's getState is a method, so it needs empty brackets. IsKeyDown is a method, so it needs brackets, but they're not empty because it needs to know which key you're looking for. And then finally, don't forget to close this bracket as well. So if the left arrow key has been pressed down, then we move the player's position. It's the X coordinate we want to change for the left arrow, so it's the dot X. Be careful and make sure it's a capital X, because that's what we're expecting, or C# is expecting to see. We're going to make it equal to its current position minus 5. It's minus to move to the left of the screen, because the screen goes left to right, 0 to usually 800. So similar things for the other keys. In fact, you know what, I'm going to copy and paste. But the right key instead of the left key will make the X coordinate go in the other direction. So instead of subtracting 5, it adds 5. And then we'll want the up and down arrows, which will change the Y coordinates. So next we need to check if the player has moved outside the bounds of the screen. These are if statements again as well. So if the player's position along the x-axis goes below 0, then the player's position along the x-axis is reset to 0. So in other words, if it ever even slightly goes below 0, it will stop and go back to 0. So it should never get below 0 in that case. Same thing for the y-axis. If the y coordinate goes below 0, then we reset it to 0. So that's the left hand side of the screen and the top of the screen handled. Next, the right hand side of the screen. Now I'm assuming the screen is going to be 800 pixels wide, 480 pixels tall, because that's the default resolution in this version of XNA. So why haven't I put 800 in for the right hand side? Well, it's because the graphic is 43 pixels wide. So we have to bring it back 43 pixels from the edge, otherwise it will go slightly off the screen. Otherwise it's exactly the same thing. Once you go past that pixel, you reset it to that pixel. And the same thing for the y coordinate. If it goes above 420, which is the screen resolution minus the height of the sprite, if it goes beyond that, then we reset it to that. This is the cheap, easy way of doing it, by calculating the numbers beforehand and putting them in. There's a better way to do it, which we'll hopefully see later on. Now for the spawn timer. make enemy spawn timer countdown, and then if the enemy spawn timer reaches 0, deal with it. So that's the next step. Well, first we need to declare a spawn timer actually. So let's go back up to the top where all the declarations are, and declare an integer called spawn timer. Integer means it's a whole number instead of a floating point, and next we need to initialize it at the start of the game. I'm initializing it to 30. This timer is going to count in frames, which isn't as accurate as serious games need, but it's good enough for now. Hopefully most computers you're going to use this on will be good enough to deal out 60 frames per second. So 30 frames means 30/60ths of a second, or in other words half a second in total before the timer runs out. Here's how to make it count down. Spawn timer equals spawn timer minus 1, so it's equal to its current value but down by 1. Then when it reaches 0, if spawn timer is less than or equal to 0, when it reaches 0 we do a bunch of code which I'm going to put inside curly brackets, and notice it's indented it for me immediately, so we know that all of these lines will happen only when the spawn timer has reached or passed 0. So what we do in that case is we create a new sprite. I'm going to call it new bad guy. Because it's inside brackets, it's only available locally. It doesn't exist once the program exits these brackets. It's temporary. But it's going to be a new sprite, and we're going to set its position along the x-axis to 800, so it's just off the screen. And then we'll set its y coordinate to the same as the player's y coordinate, so that it will spawn right in front of the player. And we'll set its velocity to -3, so it should be moving 3 pixels to the left each frame. Lastly, we need to add to the list of bad guys the new one we've just created. So even though he's temporary, once he gets added to that list, he's going to stay in that list until we remove him. And then we have to reset the spawn timer back to 30 frames. So each frame is going to count down. It starts at 30, it goes down to 29, 28, 27, etc, etc. When it hits 0, back up to 30 and start counting down to spawn the next one. There's still not much point drawing the sprites though, because only the player would be visible as the bad guys are off the screen and they don't move onto it. Let's move them onto it. We're using a for each loop this time. So we loop through every sprite and we call the current one that we're looking at this bad guy. And we're looking at every sprite in the bad guy list, which may, remember, be empty. It certainly will be at the start of the game at least. Curly brackets to contain the code for each bad guy. So what does each bad guy do? Well, its position gets changed to its current position plus this bad guy's velocity, which remember we set to -3 on the x-axis, so now it will begin actually moving to the left. What's next? Well, we've made enemy spawn, moved the enemy in the direction it's supposed to move. Now we need to check if the enemy goes off the screen, remove it from the list. Let's create a new integer called bad guy list position, because we're going to have to go through the list manually to do this properly. And we'll start at position 0. We'll use another for each loop. Similar to the last one, we'll call it this bad guy. And we're looking through each sprite in the bad guy list. So what do we do for each bad guy? Well, we check if that one has a position along the x-axis less than -40. So if 0 is the edge of the screen, then -40 means it's went past the edge of the screen, so it's actually gone so far to the left that it's went off the screen. In that case, we remove from that list the bad guy at list position, which we're going to keep track of. I'll show you that in a moment, but next we need to break. Again, I'll explain that in just a second. And lastly, the list position will go up by 1. So far what I've been saying when we're adding stuff together would be like bad guy list equals bad guy list plus 1. Plus equals 1 is just a shortcut for the same thing. So take whatever that variable is and add 1 to it. So bad guy list position starts at 0, it goes up by 1 each time it goes through this loop. And if any of the bad guys have a coordinate along the x-axis so that it's not on the screen anymore, then you remove that bad guy, because that number will keep track of which position in the list you're looking at. The break command will stop that loop. It breaks out of the loop. So once you find a bad guy that's went off the screen, you stop checking for others. Technically there might be a bug in that, but realistically there's never going to be in our game more than one bad guy going off the screen at one time. So there's nothing wrong with us doing it here. Okay, what's next? Make the enemy's firing timer count down, and if it reaches 0, do all the stuff to make it spawn a bullet. Actually, you know what? We might draw things and finish that off later, because this video is getting a bit long as it is. So in the draw function, I'm going to put in spriteBatch.begin to begin a batch of sprites that are going to be drawn on the screen. SpriteBatch is something that's built into XNA games. And then we use SpriteBatch to draw a sprite. I'm going to actually draw the player graphic. Where are we going to draw it? Well, it's expecting a rectangle, but actually we're going to use the second option, which is a vector. We've got two vectors. One of them is the player's position. And lastly, it's expecting a color. So we're going to say color.white. It's not actually going to be drawn in the color white. What that means is the tint. So it's kind of like you're shining a white torch on it. So you're getting the regular colours. If you wanted to shine a red torch on it, you would say color.red. And the sprite's colours would change a little bit towards the red spectrum. Okay, so that's basically how to draw a sprite. Let's go through drawing all the rest of them, which are the bad guys in the bad guy list. So for each bad guy, we draw the bad guy graphic. In the current bad guy's position with a white tint, or no tint really. We're not quite finished, we need to then end the sprite batch. Nothing gets drawn on the screen until the batch ends and is flushed onto the screen. If you run this, in fact, let's do that right now. If you press the run, or debug I should say, button, it'll run our game. I seem to have a bug. You can move left and right, but not up and down. The bad guys are definitely spawning and moving towards me. But it looks like I've made a mess of the controls. Still, the perils of copy and paste. Still Y's instead of X's. That's more like it. And the bad guys are spawning in front of wherever the player is. That's enough to be getting on with. We'll look at the rest of it in the next tutorial.